Okay, so hello students, welcome to our channel. So today we'll solve some numericals of quantum mechanics, and these questions are very important for your different examinations, either in bar, in your CSIR net examination, in GATE, as well as in assistant professor examination. Fine. So let's try to solve the questions. Fine. So the first question is that a wave function of a particle in infinite one-dimensional potential is given to us. This is the wave function at any time t. Fine. Where psi1, psi2, psi3 are the normalized ground state, first excited state and second excited state, and their corresponding eigenvalues are also given to us. Then what we have to find out the expectation value of energy on this random state. So how to find out this thing? So you see, first see the form of this question. Can I say this is something like this, that psi x is nothing but summation over n cn psi n? So I can say that c1 is nothing but root 2 by 3 e to the power minus iota e1 t by h cut. And what is c2? c2 is 1 by under root 6 e to the power minus iota e2 t by h cut. And what is c3? This is 1 by under root 6 e to the power minus iota e3 t by h cut. Fine. Now see how to find out the expectation value of any quantity, any physical quantity. So this formula you already know, that A is nothing but, A is any physical quantity, minus infinity to infinity, wave function psi. Let me just wait. So this is psi star A psi dx, and then the normalization of the wave function minus infinity to infinity psi star psi dx. Fine. But this formula we always use when wave function is in the continuous form or in the functional form. But अगर wave function discrete form में है, जैसे यहाँ पे है, so what we can do, we can directly use this formula, summation over n expectation values, sorry, this is eigenstate, eigenvalue, and probability of this eigenvalue on this random state psi. This formula we directly use. So we can use it for energy also. So expectation value of energy is nothing but, now I can say, summation over n energy En and the probability of finding this energy eigenvalue on this wave function. Fine. This we have to find out. I can also write it like this because we have only 3 states. So this is E1, probability of E1, plus E2, probability of E2, plus E3, probability of E3. Now what are these E1, E2, E3? We know these are the eigenvalues for the 1D box. On 1D box we know what is En. En is nothing but n square pi square h cut square over 2ma square, and I can also write it like this, n square E1, because this part is nothing but the E1 part, ground state energy. So E1, E2, E3 we already know. How to find out the PE1? So what is PE1? This is nothing but the probability of E1 on this random state, on this random state. So how to find out these probabilities? These are very simple. You know this formula also. Let me just change the color. So you know this formula, that probability of En is nothing but Cn mod square divided by summation over n Cn mod square. This formula we will use when wave function, any random wave function is given in the linear superposition of eigenstate, then you can directly use this formula to find out the probabilities. Fine. So what is P1? I can say this is C1 mod square divided by summation over n Cn square. This Cn square is nothing but mod C1 square plus mod C2 square plus mod C3 square, and I can say that this is nothing but 1. So when you do this square, so this is square of this term, square of this term, square of this term, this will give you simply 1, right? So if this is nothing but, now I can say this is 2 by 3. Now you may ask what happened to this time dependent term, e to the power minus iota e1 t by h cut. So you see this C1 square is nothing but, actually when I am saying that C1 square, this is nothing but C1 star. So when you do the C1 star, this will become e to the power plus iota e1 t by h cut. तो एक टर्म क्या होगी, e to the power minus iota e1 t by h cut, दूसरा क्या होगा plus iota e1 t by h cut. That will give you simply 1. So this is Pe1. Now what is Pe2? Pe2 is nothing but, I can say mod C2 square, and this summation, that is already 1. So this is nothing but 1 by 6. Similarly, I can say what is Pe3. This is nothing but again 1 by 6. Fine. So finally, now I can put all these things in this formula. So you can put, so expectation value of energy is nothing but, now what is E1? E1 as it is, and probability of E1, that is nothing but into 2 by 3 plus E2 into 1 by 6 plus E3 into 1 by 6. Now this 2 by 3 I can write as it is, E1 I can write as it is, plus 1 by 6. Now you see what is E2. Can I say this is nothing but, because you know this formula, En is nothing but n square E1. So for E2 I can say n is equals to 2. So this is 4 times of E1 plus 1 by 6, and this is nothing but 9 times E1. So you do this calculation, what I can do, I can take 1 by 6 common. So this will becomes 4 times E1 plus 4 times E1 plus 9 times E1. So this will give you 17 by 6 E1. This is the answer, and this answer you can match here also. This A is the correct answer. It's a very simple question, very straightforward question. आपको याद रखना है ऐसे क्वेश्चंस में कि जब भी वेव फंक्शन इस फॉर्म में दिया हो, इस तरह से इस फॉर्म में दिया हुआ हो, फाइन, तब आपको डायरेक्टली ही ये फॉर्मूला यूज करना है कि प्रोबेबिलिटी इस तरह से निकालनी है, mod C1 स्क्वायर डिवाइडेड बाय summation of mod C1 square. That means this is just for the normalization part, and then you can use this formula. This formula you can use directly. Fine. Okay then. So let's see the second question. Now see this question. So what is the question? That a particle is subjected to this potential. So a potential is defined to us that at x less than 0 and equals to 0, this is infinite, and from a to b this is v naught, and then again 0, where a is greater than 0 and b is greater than a, and energy of particle is less than this potential v naught. Then which one is satisfying the wave function of this particle in under this potential? तो हमें क्या निकालना है कि इस potential में, for this given potential, what is the wave function? तो हमें 4 ऑप्शन दिए हुए हैं, A, B, C, D. So which one is the correct option? So let's try to do this one. We use the black color. So first what I do, I'll try to draw the potential. तो देखिए potential क्या given है आपको. So let me try to draw the potential first. So if you draw the potential, so this is x is equals to 0, this is x direction, and this is the direction of our potential Vx. And at x is equals to 0, the potential is infinite. I can say at x is equal to 0, it is infinite. And at x is equals to a to b में क्या है, v naught है, and a is greater than 0. You see, a is greater than 0 here. So a is somewhere here, I can say. Let's suppose this is a, and let's suppose this is b. This is a and this is b. And in this region, the potential is v naught. And again it is 0. After this it is 0. Right? Now you see in this region, what is happening between x is equals to 0 to a. So in this region also potential is 0 because आपको कुछ भी given नहीं है. So you can consider this as a 0. Now let's try to draw the wave function. So you see, let me just change the color. What is the wave function? Just think about it. What should be the value of wave function at x is equals to 0? At x is equals to 0, the potential Vx is infinite. And this we already know, whenever potential is infinite, the wave function is always 0 at that point of time. So that means at x is equals to 0, the potential is, at x is equals to 0, potential is infinite. That means wave function is 0. ठीक है, याद रखने काम आएगा, मैं आगे बताऊंगा कैसे हुआ है. Now second thing, what is happening in this region? X is equals to 0 to a. In this region, so you see in this region potential is 0. And when I'm saying that potential is 0, can I say that wave function is the free particle wave function? Because potential 0 है, इसका मतलब external force 0 है. Force 0, so I can treat that as a free particle. And for free particle wave function we know किस तरह का wave function होता है. Psi x is nothing but a to the power iota kx, right? Or if you draw this potential, this is something like this. This is the free particle wave function. Fine. तो यहाँ भी कुछ ऐसा ही होगा. So it will go like this, something like this. Now what is happening in this region? Again you see in this region we have some constant potential v naught. So again in this region, you see in this region we are considered, let's suppose it is already given to us कि एनर्जी क्या है उसकी v naught से कम है. तो आपने ये देखा होगा स्टेप पोटेंशियल वाला केस. जस्ट थिंक अबाउट द स्टेप पोटेंशियल. इफ इन स्टेप पोटेंशियल if potential is v naught और इधर से कोई पार्टिकल आ रहा है यहाँ, and this is the energy, and if energy is less than v naught, तो क्या होगा उसका wave function? It is a decaying wave function, exponentially decaying wave function e to the power minus gamma x. ऐसा ही पढ़ते हैं हम, that this we already know. So यहाँ भी कुछ ऐसा ही होगा. This is a constant potential, so in this region it will be a decaying wave function like this. Fine. Now after the b again in this region, you see in this region potential is again 0, so particle is free particle, so it will be the wave function of free particle. So I can say this will be the wave function of free particle. So very simple, right? Now you can match the answer. So आप देखिए यहाँ से first option incorrect, right? Second option incorrect, third option and fourth option. अब आप ध्यान से देखिए यहाँ पे, see this B and D option, this one and this one, they both looks like same, but I'm saying the correct answer is B. This is correct, this is incorrect. Why? Just focus here. ये छोटी छोटी चीजें हैं जो आपको एग्जाम में याद रखनी है. Just focus at this point. In this D, the wave function is started at some value. They have given some value of the wave function at x is equals to 0. But technically, we know that at x is equals to 0, potential is infinite, so wave function should be 0. It must be 0 at x is equals to 0. So that means this is the correct answer. So these are the very small things or minor things that you have to understand. Fine. So very simple question. Okay then. So let's see the next question. Just change the color. Okay, so the question is, the wave function of a particle is given in this form. आपको एक wave function given है this form में. Let's suppose given wave function is e to the power minus iota ax. So this is alpha. Let's consider this as alpha x and this is beta. So let me just write it again. Just wait. The wave function is exponential minus iota alpha x plus beta, right? I can also write it like this, e to the power beta into e to the power minus iota alpha x. This e to the power beta is some constant number, so I can write it like this, some constant a e to the power minus iota alpha x. This is the wave function, and alpha and beta are the real values. This is also given to us. Which one of the following is the potential for this wave function? हमें क्या निकालना है कि एक पार्टिकल है जिसका वेव फंक्शन गिवन है और हमें निकालना क्या है, पोटेंशियल निकालना है. कैसे करें? तो जब भी इस तरह के क्वेश्चंस आए आपके पास, हमेशा याद रखो, whenever you face this kind of question, when wave function is given to us and they are asking about the potential, then always use the equation of Schrodinger. Always use the Schrodinger equation in this kind of situation. So we know the Schrodinger equation, minus h cut square by 2m del square psi by dx square plus Vx psi is equals to energy E psi. For this case, wave function is given to us. This is our wave function. So what is d psi by dx? I can say this is minus iota alpha a e to the power minus iota alpha x, and what is del square psi by dx square? This is again minus alpha square a e to the power minus iota alpha x. आपको सिर्फ डिफरेंशिएट करना है. Can I write it like this? This is minus alpha square again psi x. This is the wave function. So I can put this wave function into this equation 1. Just put. So this is minus h cut square by 2m, and then this function minus alpha square psi plus Vx psi is equals to E psi. And you can also write it like this, minus and minus plus. This is h cut square alpha square by 2m, and then this is plus Vx, and then psi is equals to E psi. Now see this carefully. This is something like this. H psi is equals to E psi. This is the form where H is the Hamiltonian. And for this equation, we always know that Hamiltonian is conserved. Hamiltonian is conserved, so its eigenvalue, or I can say its energy, is always conserved, so it will be some constant value. Now think about it कि कैसे constant value आएगी यहाँ से. तो जब भी इस तरह के क्वेश्चन करना हो और आपको पोटेंशियल निकालना हो तो क्या करेंगे हम यहाँ से, जितनी भी x डिपेंडेंट टर्म होंगी that we always put equals to 0. तो यहां से x डिपेंडेंट टर्म क्या है, दिस इज Vx, क्योंकि हमें सिर्फ एनर्जी कांस्टेंट चाहिए. सो कैन आई से दिस एनर्जी इज ऑलवेज इक्वल टू दिस वन, राइट. क्या मैं इसे इस तरह से भी लिखूं आपको, E इज नथिंग बट h कट स्क्वायर अल्फा स्क्वायर बाई 2m प्लस Vx, बट एनर्जी शुड बी कांस्टेंट बिकॉज हैमिल्टोनियन इज कंजर्व. तो क्या होना चाहिए यहां से, मैं कह सकता हूं I can say this Vx must be, we'll put it equals to 0. We'll put it equals to 0. Fine. So here you can see this potential is 0. C is the answer. ऐसा भी हो सकता, ऐसा नहीं आपको सिर्फ Vx को 0 पुट करना है, जितनी भी x डिपेंडेंट टर्म होंगी, क्योंकि यहां हमारे x डिपेंडेंट कोई टर्म आई नहीं है. सपोज कुछ इस तरह से टर्म आ जाती है हमारी यहां पे, मैं जस्ट आपको एग्जांपल दे रहा हूं. Let's suppose instead of this, just focus here. Instead of this, you will get some kind of this thing. X cut square alpha square by 2m plus Vx plus some term of alpha. Sorry, this x. Let's suppose alpha x square plus beta x. कुछ भी इस तरह की टर्म आ जाती, right? Psi is equals to E psi. तो आपको क्या करना है, जितनी भी x डिपेंडेंट टर्म होंगी उनको क्या करेंगे, हम 0 पुट करेंगे. सो विल से दैट Vx प्लस अल्फा एक्स स्क्वायर प्लस बीटा एक्स इज इक्वल टू 0. तो यहां से पोटेंशियल क्या आ जाता, Vx इज नथिंग बट माइनस अल्फा एक्स स्क्वायर माइनस बीटा एक्स. दिस इज द पोटेंशियल. दिस इज द थिंग विच यू हैव टू फॉलो whenever they ask the potential and wave function is given to us. Fine. इस क्वेश्चन में आपको इतना करने की भी जरूरत नहीं थी, आप डायरेक्ट भी बता सकते थे दिस इज नथिंग बट द वेव फंक्शन ऑफ फ्री पार्टिकल. देखिए बिना देखे भी आप कर सकते हैं, दिस इज नथिंग बट द वेव फंक्शन ऑफ फ्री पार्टिकल. और फ्री पार्टिकल का वेव फंक्शन जब ये है तो फिर फ्री पार्टिकल का पोटेंशियल क्या होता है, दो ही पॉसिबिलिटी हो सकती है फ्री पार्टिकल में. द पोटेंशियल आइदर मस्ट बी 0 और दिस मस्ट बी कांस्टेंट, बिकॉज दोनों ही केस में हमारा फोर्स क्या होगा, माइनस dv by dx, this will be 0. Fine. So this is how you have to deal these kind of questions. Okay, then next question देखते हैं. Okay, this is very interesting question and it is related to the perturbation. And remember, perturbation के questions हमेशा आते हैं. Fine. And very very important question. See the question. Again, I'm saying you have to be just focus on the concept also in perturbation. So question is particle of mass m in infinite potential well. This is infinite potential well of width a. So width a, that means width from 0 to a is given to us, and this is the perturbation v dash shown in the figure, right? The first order energy shift in the fourth energy state due to this perturbation is this. ठीक है, then what is the value of n? So देखिए क्या गिवन है आपको, इस तरह का एक perturbation दिया हुआ है, राइट. इसकी फोर्थ आइगन स्टेट में ये एनर्जी में करेक्शन है. तो देखिए क्या होगा, फ्री पार्टिकल है, सॉरी 1D बॉक्स में है पार्टिकल. तो 1D बॉक्स के लिए मैं परटर्बेशन को कुछ इस तरह से लिख सकता हूं, h इज नथिंग बट h नॉट प्लस दिस v डैश. सो दिस h नॉट इज द एक्चुअल पोटेंशियल और एक्चुअल हैमिल्टोनियन एंड दिस v डैश इज द परटर्बेशन. सो फॉर द एक्चुअल सिस्टम जहां परटर्बेशन नहीं है, हमें ऑलरेडी पता है वेव फंक्शन क्या होता है फॉर एनी nth स्टेट अंडर रूट 2 बाई a, because this is from 0 to a, asymmetric potential, sin n pi x by a. And what is energy En? This is nothing but n square pi square h cut square over 2ma square. This is energy. This is for the actual system, real system, जहां perturbation नहीं है. अब perturbation given है आपको, तो जब भी perturbation given हो और फर्स्ट ऑर्डर करेक्शन इन एनर्जी निकालना हो तो क्या फॉर्मूला होता है, वी कैन यूज द डायरेक्ट फॉर्मूला, दैट इज नथिंग बट ई एन डैश फर्स्ट ऑर्डर करेक्शन इन एनर्जी, एंड दैट इज नथिंग बट पाई एन द परटर्बेशन एच पी. इसे आप एच पी भी लिख सकते हो, दिस एच इज नथिंग बट h naught plus hp, and sometimes you can also write it like this, h naught plus lambda w. So whatever is the perturbation here, you have to just write it here. So this is hp phi n. ठीक है, तो आपको क्या करना है, बेसिकली इस परटर्बेशन की एक्सपेक्टेशन वैल्यू निकालनी है इस रियल वेव फंक्शन पे फॉर एनी nth स्टेट. नाउ यू सी इस क्वेश्चन में आपको क्या दिया हुआ है, फॉर फोर्थ एनर्जी स्टेट. ठीक है, तो हम क्या करेंगे, इसको डायरेक्ट nth स्टेट के लिए ही करते हैं. ठीक है, डजेंट मैटर कि आप किसके लिए कर रहे हैं. आप फोर्थ के करेंगे तो n इज इक्वल टू 4 भी पुट कर सकते हो, दैट डजेंट मैटर. फाइन. So just put this potential here. So this is nothing but phi n. What is this? This is nothing but v dash. You see this v dash is some number. This is some number. So what is E n dash now? Now you see this v dash is some number, so I can take it outside. So this is nothing but v dash phi n phi n. So what is this thing? अब आपको ये देखना है, तो ये कैसे निकालेंगे, v dash लिमिट phi n star phi n dx and what should be the limit here. तो लिमिट देखें, यहां से ध्यान से देखिए कि परटर्बेशन किस रीजन में हो रखा है. द परटर्बेशन इज ओनली इन दिस रीजन, ओनली इन दिस रीजन. यू सी दिस इज द परटर्बेशन. यहाँ ऊपर दिया हुआ है, थोड़ा पोटेंशियल ऊपर चला गया, देखिए सडनली इतना ऊपर चला गया. दिस इज द परटर्बेशन रीजन. तो क्या लिमिट होगी, दिस पॉइंट इज एट 3a/4 एंड दिस इज एट a. सो लिमिट इज 3a/4 टू a. नाउ यू कैन सॉल्व दिस इंटीग्रेशन. आपके पास में वेव फंक्शन ऑलरेडी गिवन है, आप इसमें पुट करिए एंड देन यू कैन सॉल्व दिस वन. E n dash is nothing but v dash, this is 2/a, limit is from 3a to 4a, and this will give you simply sin square n pi x by a dx. You can solve this integration, but मैं आपको डायरेक्ट ट्रिक बताता हूं एग्जाम में कि आपको इस लिमिट रख के सॉल्व करने की जरूरत नहीं पड़ेगी. हाउ, जस्ट फोकस हेयर. Let me just change the color so that you can understand. Just focus here. What is this term? Just focus on this term. If I ask you what is this phi n in the limit x is from 0 to a. अगर लिमिट 0 to a होगा तो ये क्या होगा, ये टर्म किसको रिप्रेजेंट करती है. Can I say this is nothing but the probability of finding the particle in this region, in this whole region. यहां से यहां तक जितना भी probability होगा, this represents that probability and that probability is 1. So can I say this is always 1 in this region? आप normalization के लिए भी ये यूज करते हैं, right? अगर मैं आपसे पूछूं what is this phi n when limit of x is from 0 to a/2, क्या होगा. Can I say this is nothing but the probability of half of the region in this region? So can I say this probability is nothing but 1/2. आप इसका सोल्व करके भी निकालेंगे यहां से भी, तब भी वही निकल के आएगा, बट मैं डायरेक्टली बता रहा हूं. दिस इज सिंपली 1/2 बिकॉज हाफ ऑफ द प्रोबेबिलिटी इन हाफ रीजन. तो इस रीजन में हाफ है तो इधर भी हाफ ही होगा प्रोबेबिलिटी. दिस ऑल्सो 1/2. नाउ व्हाट इज द प्रोबेबिलिटी इन दिस रीजन, ओनली इन दिस रीजन. दिस इज द 1/4 ऑफ दिस होल रीजन. यू सी दिस इज a/4 रीजन. This is a/4 region. So in this particular region, can I say when this is from in this particular region, this probability is 1/4. So I can say that phi n is always 1/4 when x is from 3a/4 to a. Right? This is 1/4. So I can directly put this value here. So this is not here. Just see this one. मैं यहां से यूज कर रहा हूं, देखिए. So this E n dash is nothing but V dash n to 1/4. Now what is V dash? This is h square by 40 ma square into 1 by 4, right? So you can also write it this. This is h square divided by 1 by 60 into ma square. Now you can compare with this one. If you compare with this one, so I can say that the value of n should be 1 by 60. This is 1 by, sorry, not 1 by 60, sorry. This n is simply 160. Fine. This is how you can deal with these kind of questions. क्योंकि आप देखिए, अगर आप इस इंटीग्रेशन को सॉल्व करने बैठेंगे तो आपको बहुत लंबा टाइम लगेगा. इसको 1 माइनस कोस के फॉर्म में लिखना पड़ेगा. Then you have to do the integration, then you have to put all the limits here. It will take lot of time. ठीक है, तो जब भी इस तरह के क्वेश्चंस हो आप इस तरह से देखिए, क्योंकि यहाँ कोई x की टर्म तो है नहीं. आप डायरेक्टली दिस वी ऑलरेडी नो दैट दिस रिप्रेजेंट्स द प्रोबेबिलिटी ओनली. तो प्रोबेबिलिटी भी किस रीजन में है, आप पूरी प्रोबेबिलिटी कितनी है इन दिस रीजन, दिस इज 1. तो 1/4 1/4 1/4 4 पार्ट्स में डिवाइड करेंगे तो प्रोबेबिलिटी इज 1/4 1/4 1/4 1/4, राइट. And also it is independent on the eigenstate. This we are doing for any nth eigenstate. तो कोई मैटर नहीं करता कि वो 4th में है, 3rd में है, 5th में है, ग्राउंड स्टेट में है. It doesn't matter. Fine, because we are doing for the any eigenstate nth. Okay. Okay, then this is all about today. Thank you.